Hello everyone. Today we were here to present our own project called Fire Alarm with Localized Mesh Technology and Auditorial Announcement System utilizing the ESP32 Development Board of Flame. Now, as you all know, in modern days, the traditional fire alarm still has some problem, such as its inaccuracy along with the way these alarms sound, which tends to lead to mass confusion and panic. The other problem is that a large fire alarm system usually require a lot of equipment and wiring, which would often lead to a high cost in its installation. Also, in our literature review, according to a 2018 study in the subject of false alarms, they found out that there were more than 312,000 false alarms in Great Britain in the year 2012 to 2013 alone, further proving our point on false alarms being a problem. Moreover than that, we also have first-hand experience as well. Having spent 2 years in a dorm, we have seen our fair share of false alarms. So our solution to all of these problems is that to create our own fire alarm system that can overcome all of these problems that the traditional fire alarm face. So the objective of our project is that to create a hassle-free alarm system with interconnected alarms working together with no limitations of traditional fire alarm. Next part is our methodology with Mr. Tanabadi.
Our methodology begins with research and development. We started by researching into traditional fire alarms and detection types. And in the end, we chose the MQ2 gas and smoke sensor for its capabilities. Next up was chip selection. Selecting a microprocessor to be the brains for our project was hard work, having to balance between processing power and efficiency. After days of researching and comparing, we ended up with the ESP32 as our final pick. After that, we started component selection. Aside from the chip, other components such as PSU, UPS, batteries, and amplifiers are also very important, and having them work safely together is a must. After all that's done, we started coding and debugging. We spent much time here to make sure the code would work flawlessly between the devices in our system. The code itself was done mostly in Arduino IDE, and around 1,000 plus lines were ever written. And then it was time for testing and troubleshooting. The components were assembled onto a test bench, which allowed us to test how the system would work on normal conditions. After any problems were dealt with, we then moved on to assembling the units. So finally, we have assembly and quality check. With the system working as it should, assembly was then underway. Finally, after connecting each unit, we then did a quality check on all systems to ensure longevity and to ensure they are performing as they should. Next are our results. We will be sending information onto a complete unit to see the response. First is a demo for reporting a new fire in another room. Second is a demo for stopped fire in another room. Finally, it is time for our conclusion. We have developed a fire alarm system which can be installed wirelessly throughout the building with the use of mesh technology, complete with both localized and system-wide auditory announcement systems and various other capabilities that the commercially available fire alarms lack. Thus, we are certain that this new fire alarm system can solve most of the ever-occurring problems in traditional fire alarms, and once miniaturized and optimized, can become the impending standard of fire alarms throughout the market in the near future. On behalf of my partner and I, we would like to thank you for your attention. Thank you very much.